warehousing and also give a little bit of an overview about how we have come across all this, brief history also. I'll be talking about how we came to this spot right now where we are with the data pipelines, and how we have evolved ourselves throughout these years. So that'll be my main topic for today. If I'm not able to see you all in the question answer session, feel free to ask questions in the chat and I'll try to answer. But I'm not able to see the chat right now. I'm Gayatri Balakumar. I've been working in this banking and finance industry for a while now. I've worked across major US banks like Bank of America, Citi, and currently I'm in Capital One. And I've been working with data architecture, and also I've been leading some of the generative AI initiatives recently. And as a part of that, I've started like attending these kind of hackathons and trying to connect with people. And also I'm doing mentoring for engineers who are just coming out of university and trying to step into the data engineering field. This is one such presentation where I feel this will kind of give you understanding, more than tools and everything. The tools keep changing every day, but you'll get a holistic idea of what is expected out of a data engineer when you go to a enterprise level company, and what we are trying to really solve. How we came here? How did data warehousing come into picture, and why we started doing all this, right? This is like a little history that I'm showing here, how it evolved. That said, we also came, like, when you go to shops and buy something in the 1900s, probably the ledger acted like a data warehouse, right? Whatever we have as tables today was probably being written into small books. And even our fathers would have had, like, or our mothers would show, like, where they wrote things rather than entering into an Excel sheet. And that is what was the primary data warehouse that came into existence in our history. And what that gave is, like, the shopkeeper might probably know, okay, the stock of sugar is getting over and I have to restock. But that would only work when there is a local business going on. With the advent of uh, business analytics, and with the globalization, with more and more people coming into retail and trying to move around, and constant money movement is also there. There was a little bit of, and with also the advent of computers, we started using somewhat like a small, a moving on from like paper trail to a computer based data trail. So we started storing data in computers, saying that, okay, this is the sales that has been going on. What happened in the late 70s or early 80s in the US was, in the beer section and the diapers were started to, were put together. You would not see that in a department store right now, but some of the early data analysts, what happened was, in that period of time, the most of the men were not, they were not able to get jobs, so they started doing, taking care of the children. So they always went out to buy diapers for their baby, and then they also took up a case of beer. So this is sort of a retailers understood there was some correlation going on. And since they noticed this with their, with the bills, or their, the pattern of people shopping, they did this. Another story of data warehousing goes into the 9/11 flag sales, where uh, even though the 9/11 attacks are happening and the US was, like, not feeling that well sentimentally, but what Walmart noticed was the flag sales were going up. So they tried to put a lot of flags into one shop, and I think they made to a close to $1 million just with the sales of flag during this event. So this also shows there were some analytics that were being done even before the advent of cloud, and with basic computer technologies and Excel. Probably we had some sort of like tables and database. With that, they did all these, like, minimal analytics were done. And then slowly we move into the world of legacy tools. Something called as ab initio was I want to highlight today, but there were like similar tools like ab initio, talent was there. And what they helped us was, we can't like, constantly figure out everything with a minimal effort. So what we needed was uh, the data, as the data volume was going up, we needed some sort of a tool that can help us with extracting and transforming and loading these tables. And it was heavily used in financial services, telecommunications, and retail to figure out what was the next offer that they could push to customers and how they could solve certain business problems using these tools. Um, as you can see, this is a sample like ab initio data pipeline, and you can have your input file, and you would have all these different data warehousing functionalities as different, what can I say, widgets. And then you would like, pull and you will use it and try to transform your data. What we noticed with ab initio was there were some limitations, right? So we had to pay a lot for the cooperating system license, and there were only a small pool of skilled developers, meaning there were not a lot of people that were trained on ab initio, for example, or the legacy tools. I'm just picking an example here. So we were also seeing that it was not very scalable. We were only able to do a certain number of data during a certain number of times. So as the data goes up, we were also kind of hitting a block on how would I scale this for another set of population, or how would I always, there was a challenge of chunking the data. And also it was not open source. So you would also not have that many skilled developers like you had for Java or Python. So it was very closed group of people that were working on these kind of tools. Then what we have noticed is the rise of big data and PySpark on EC2 instances. So around 2010s is where AWS came into picture, and they were releasing something called as EC2 instances. And Python was also on the rise for data warehousing jobs. And we also had we were starting to like take out these transformations that we wrote into these traditional tools and bring it into a EC2 based system. And this is where I think the rise of big data, as in like Spark, Python, were clubbed together to solve business problems. And this one gave us more flexibility because it was like an open source tool, right? Spark was also open source, Python was also open source. And so we were able to understand, and it was fairly simpler to write small transformation jobs. And it was also cost effective compared to legacy licenses, like the license we paid for other legacy tools were very costly. But here you are only spending it for the EC2 instances, and you're only spending money when you run the job. I want to like highlight a few things that happened in this Hadoop slash Spark era. We also transitioned away from the expensive and proprietary tools. We were able to use Apache Spark, and Spark became the standard due to it's like it was having a good memory processing, and it worked well for big data because of its lazy evaluation and distributed processing, and we were able to process large scale data. And also the architecture and implementation was a little bit infrastructure heavy because we were involving Amazon EC2 servers, which was like a blank slate. Now you take up the EC2 server, you have to install Spark on it, and then you have to make sure your jobs are running efficiently. You had to have certain level of distributed storage knowledge in order to optimize these jobs and making sure they're not exceeding a certain cost. Data transformation logic was written by the data engineer. So that is also like, kind of we had a DevOps person who would set up all our clusters, and there were data engineers who wrote the transformation logic. And we also used PySpark or Scala. So there was one level of learning that had to be done. So people had to know how to set up the clusters. People had to know how to set up the PySpark jobs or Scala jobs. And also it was The only advantage to the previous world was it was more open source and also cost effective. And also it was scalable as EC2 servers, you could add more EC2 servers as you see the data need go up. Then we came into a world of EMR, where we had what Amazon came up with was there was a transition from EC2 to EMR just for these data pipelines. The reason being EC2s are nothing but, EMR clusters are nothing but EC2s, but EMR clusters came in with the required big data tools like Spark, Hadoop, Hive, Pig, everything, Flink. You could configure whatever you need in your EMR cluster. And also you could like integrate it with S3s and your Lambda whenever you wanted a job. You could set up your PySpark jobs within EMR. And all you had to do was, you had to know how to provision your and configure your EMR cluster. And that's what the difference between EC2 and EMR. In EC2, you had to manually install all the big data softwares, requirements, and all the other overhead you had, but EMR reduced that overhead a little bit. Still, there were thinkings about you had to spend quite a number of time about thinking about server cluster startup times, how would I spin up my EMR, and all that still. This is a sample EMR cluster where you had to you had data sources come in. Your PySpark jobs would run within your EMR cluster. And probably here I'm picking up an example of Snowflake. And this target data warehouse could change based on your company. Some companies directly go to S3 again and then read using Iceberg. But traditional companies, most of the companies where you have multiple data analysts consuming your data, this is like a base data warehousing architecture that would happen 99% of the time. And so we have a source, we have our transformation, and we have our data warehouse. Still, now we have not yet solved the problem, because I want to highlight the advantages of serverless here, because EMR clusters, you're still provisioning, you're still maintaining your cluster, and it is still not completely serverless because you have a server running and you have to maintain it. And that is where our serverless revolution comes into picture using AWS Glue. So now AWS Glue is a completely serverless ATL service. You don't have any infrastructure to manage. As a data engineer, you need not understand how the clusters are working, because that is not where the actual value comes from. Right? As a data engineer, you're supposed to focus on the business logic than the underlying platform. So you can completely forget about the platform. All you have to worry about is writing your PySpark job and making sure you are able to set it up on your Glue job. And then also, one more advantage that serverless brings is you need not worry about the orchestrations, because step functions are going to help here with orchestrating our Glue jobs. As long as you have a step function, which is also serverless, you could have your Glue jobs within your step functions, and you can trigger it using any event like a Lambda or event bridge. And you can also schedule it as per your need. So for example, let's say there is a batch job that I would like to schedule every day at 8 a.m. I would have my step function go and say that, hey, I would like to, you would connect your step function to an event bridge that would say like, this is the start time of the step function. And inside your step function, you would have your different Glue jobs. And your Glue jobs would have these various Python or PySpark functions. And this is where as a data engineer, you're able to focus on the actual business problem, writing the transformations rather than supporting whether it's EC2, EMR, you need to worry about the clusters. So how many clusters I need to spin up? And did I give the right number? In Glue, those overhead is already taken out, and AWS will manage the cluster on their own. And you also need not worry about how to orchestrate. Like, so for example, in EMR, you have to think about some kind of a tool like Airflow or Arrow to schedule your jobs. Here, you're all in on AWS, and no outside tools are needed for this particular orchestration or lineage. And another good thing for lineage is you have your Glue crawlers, and Glue crawlers will automatically know what is your input data and what is your output data. And as a data engineer, the question often comes, right? Hey, what is your upstream source? What is your transformation? Or what is your downstream? And glue crawlers are going to help us here to figure out all the upstream data and the downstream data as we have all the functionality inbuilt within AWS. So a serverless architecture, like a sample one, would look something like this, right? So you would have your source data that you would pull from somewhere from S3, and you would have your PySpark transformation written in Glue, and you would publish the data in a data lake. And then once your data is published in data lake, there will be a business user or an interactive, the analyst would come up and see how the data is, or they would consume it for further modeling and as per the customer requirements. So this is how our sample serverless architecture would look like. And if you see here, this can go within a step function. Our glue jobs can go within a step function, and all of the glue jobs will be orchestrated within within a step function. When I say orchestrated, you could set up like, I want to run a glue job A first, followed by B, and then the final jobs would be C, which will load my data. So you could definitely set the dependencies that, hey, this is my predecessor and this is my successor. You could also set your glue catalog for lineage, and also you could set up the lake, which is also S3 and which is also seamlessly works within AWS. The power of glue catalog is nothing but like, it has a unified view of data across different silos. So let's say in your traditional data pipeline, you have your transformation running in EMR, and you have to, like, someone from business or a non-technical background comes in and says, hey, where is my data coming from, right? You are having the manual job of going and figuring out, okay, this is my upstream. Somebody has to document, and documentations naturally expire unless someone maintains it. So this is where the crawler's advantage comes into picture. So as soon as you implement the glue job and you have your data populating from S3, the crawlers can automatically discover the schema and also populate the catalog. So that is where the main advantage comes in, where we are able to visualize the flow of data from source to destination. So especially when it comes to debugging. So let's say there is a customer and they are expecting a value of employee ID in the end table, and they are not able to see it. So they have raised a defect saying that, hey, the employee ID is null. Can you help us look into it, right? So now you are picking through code and seeing where the data got dropped. But in terms of a glue catalog, you don't have that, and it is easy to follow the flow of data from source to destination, and you can easily understand the dependencies and help the customer figure out exactly where the issue is. And also it is you can also easily transform raw data files into queryable governed data lake using this approach. So building a serverless pipeline, right? So this is where I wanted to, like, kind of give you an idea. If any one of you have a AWS account, what you can easily do is you can have like some public data set you can pull and put it into the data S3 data bucket, and set up a simple glue job that is going to, let's say, for this understanding glue purposes, we will just say that, hey, I'm going to read this data and throw it into a table, right? This is all we are going to do. But the minute we set up the glue job, we are able to, visualize the source and the target. And we are able to see that as soon as we run this job, we'll be able to see that, okay, this is the source, and each of the columns is also mapped into the lineage, so that you're able to exactly see the flow of data from source to target. Also, you're able to visualize and data lineage, and this is also helpful for schema evolution. Let's say there is a new column added in the future, the glue catalog automatically adjusts itself according to the new schema. I also brought in a sample code that will help you figure out this in case of setting up a glue job. So this is the sample glue job that you will set up. So in S3, you will store like a I just gave a sample name called United Hacks. This will be our S3 bucket name, and you will have your, let's say, your test data placed here, or any public data set that you can pull in from Google placed here. And let's say we read that data, and then we transform this into a snowflake table, and then we'll give our snowflake password here, and then we can write this into a snowflake table. So this is a simple data pipeline, right? So probably you'll have a basic transformation here that I gave it as drop duplicates. This can be expanded into our actual transformation based on the customer needs. They might have calculations, for example, calculating the, let's say, the sum of total customers that purchased a particular product will be our sample transformation. So you can include that here, or the number of people participated in the hackathon, for example. So that can be our transformation here. And based on this transformation, so where would you get this transformation from? As soon as you work in a data warehousing company, or you are a data engineer responsible for a data warehouse, you'll be having these interactions with your data analysts or your business stakeholders. And this is your main part of your job, is to understand that problem and convert that problem into a SQL transformation, and also provide the best architecture so that it is cost effective, and it's easily maintainable, and also a less overhead on the infrastructure. So that is where I would like to bring in the serverless pipelines for your knowledge, and start using this, and you can start learning that this will help you in your day-to-day job more, and also will add value to the company by saving a lot of cost, by not worrying about the cluster, and also running it in a serverless mode where there is no dependency on external tools. So you're saving money on paying less to the external tools, and paying only for whenever your job runs, that is where you're going to spend your money. And for Glue, and I will stop here. Any questions based on what you listened so far? Hey, Miguel, thank you. Thank you for asking that question. So, what is the best way to get into tech in this generation? So, definitely, attending these kind of hackathons is going to help, and constantly, like, networking with the tech folks who are in this industry. So, I spend at least an hour every day on LinkedIn, and definitely attending meetups, hackathons, and networking with fellow data engineers and similar professionals in the industry would definitely help. Is it okay to use AI? Definitely. So AI, we have already built one pipeline using generative AI. So like I showed you this serverless pipeline, right? So we had to figure out the right number of Spark or Glue worker types to use. And we used generative AI to build a pipeline to even figure out the number of Glue workers. How did I get into this industry? This was my first job as soon as I got out of college, and I've been working ever since. So I built myself and learned during my mistakes, and I've dropped production tables. There is like nothing we can learn without making mistakes. So I kept working, and there were opportunities that kind of built one after the other. So I just built myself along the way by working across different companies. So definitely, yeah, definitely feel free to connect with me on LinkedIn. I also spend like more than 2 hours, and definitely it is more, but I keep learning more stuff, and I learn a lot of tips and tricks on LinkedIn. I follow certain people like who are specifically talk about data, like Zach Wilson and Aishwarya, and I followed certain people even today. So definitely would be happy to answer all your questions. And do connect with me on TopMate as well. Definitely. You can search with my same name on LinkedIn. So I will also post my LinkedIn profile here. Thank you, everyone, for this question. Thank you. I tried my best to encompass all the different technologies that we have built so far. Thank you.